So I'd like to welcome you to our talk from Professor Dr. Irina Gurovic regarding Adapter Hub Playgrounds, Simple and Flexible Few-Shot Learning with Adapters. Irina is a full professor at Technical University of Darmstadt and is received several awards for her field of research. And today she will present her current research topics. Thank you so much, Irina.
Thank you very much for the kind introduction. Good afternoon, everybody. I'm really delighted to be here, and I'm here not alone, but together with Tilman Beck, who is the first author of the work I'm presenting today to you. So you can see Tilman here, and he will also be available for the question-answer session later. So the project Adapter Hub Playground is a joint project of the University of Darmstadt and the University of Mainz. In particular, we collaborate with social scientists, researcher at the University of Mainz, and also in this project we have a student team involved from the students of computer science. Let me see how I can move the slides. Okay, so at the beginning, I would like to give you a quick overview of the role we envision for the Adapter Hub Playground. We imagine the scenario where a researcher has collected some data and wishes to perform an automatic content analysis using text classification technique. In this example, this is sentiment analysis. A labeled test set is available to evaluate the performance of a classifier. And also a set of texts from the same data distribution is available as training data. However, it is not annotated. Within natural language processing, or NLP for short, large pre-trained language models have significantly advanced the state-of-the-art recently. These models are published through open access libraries like, for example, Hugging Face or Adapter Hub, such that everybody is able to download them and use them for their own tasks and data sets. However, without having the required domain expertise in natural language processing, it remains very difficult to discover and make use of such models. This is where the Adapter Hub Playground application comes into play. What we want to do is to provide an easy-to-use and code-free access to state-of-the-art NLP models to researchers from other areas. At the same time, we as NLP researchers hope to gain insights into the applicability of our models in domains different from what the models have been trained on. Let me briefly introduce the structure of my talk today. First, I would like to motivate our Adapter Hub Playground framework by answering the question what problems we want to solve here. Next, I'm going to provide you some background on the technical concepts which are behind the Adapter Hub Playground. And then I will give you an overview of the application architecture and results of an exemplary scenario which we envision the application to be used for. Finally, I will demonstrate the framework in a short video. In the next slides, I would like to start with the motivation of our framework. Natural language processing research has gone a long way over the last decades, especially deep neural networks gained momentum in NLP, leading to significant progress. Most prominently, word embeddings were introduced in 2013 and advanced our state-of-the-art significantly. Neural models have been used in the form of sequence-to-sequence models or leveraging powerful mechanisms like attention. Late 2018 marked the beginning of the era of the large pre-trained language models like BERT being the most prominent representative of that category of language models. And those models significantly pushed the state-of-the-art in NLP further and advanced the capabilities of what can be done with the help of NLP. The large success of pre-trained language models, both in academia and industry, was also accelerated by their dissemination through open access libraries like the Hugging Face repository, which I have already mentioned. The advantage is that such libraries can be actively managed by some researchers or companies, and therefore there is a focus on high usability and good documentation. They also act as a community-driven model hub, meaning that the community can upload new models trained on specific tasks continuously. They are open source, so one can adjust the code to individual needs and advancements. This is additionally driven by the community through bug reports and feature requests. And of course, the libraries provide state-of-the-art models for various tasks and languages in NLP, which can be used off the shelf. Now, if we take a look outside of NLP research, we can see that several text classification tasks, which are prominent in NLP, are also the subject of interest in other disciplines, especially in the social sciences. The need for an automatic analysis is of growing interest due to many reasons, of course. And most importantly, researchers are faced with an increasing data load, which makes manual analysis unfeasible. And further, new sources of information like social media are gaining attention in multiple research disciplines due to their increased usage by lay people. Automatic content analysis also allows for a more timely investigation of temporal dynamics in media outlets. And finally, to be able to draw valid conclusions based on automatically classified text, we require sufficient predictive accuracy. However, the methods which have been used so far are not on par with state-of-the-art in NLP. If we look at the literature in subjects or in disciplines other than NLP, we can see, for example, that often they use dictionaries. While being an interpretable method, dictionary-based approaches require domain expertise, and they do not generalize well outside of the target domain. They have to be manually crafted for each task again, thus limiting their usability outside of the task they have been created for. And feature-based machine learning approaches are laborious to create and to tune. So feature engineering has been largely replaced with the use of word embeddings. Here, the problem is that word embeddings are not suitable to take context into consideration, although it is well known that a word's meaning depends on the context a lot. In conclusion, we assume that the lack of NLP expertise is the limiting factor for the application of NLP in the interdisciplinary research, and this is where the Adapter Hub comes into play. Over the next slides, I want to provide you with some technical background on the methods that we apply in the Adapter Hub Playground framework. With the introduction of large pre-trained language models, we have this pre-training fine-tuning paradigm that has become the prevalent method for domain adaptation and task learning in NLP. It is divided in two stages, pre-training and fine-tuning. And first, in standard pre-training, the model is trained on large text corpora without the use of human annotated labels. So it learns sort of general language knowledge. In a subsequent step, in the step of fine-tuning, the model is trained on a specific task with labeled data. And this is why it's called fine-tuning. So the generic model is fine-tuned to a specific task. In general, this procedure is also often referred to as transfer learning because we kind of transfer the knowledge that we have gained from pre-training to the specific downstream task. So in this example, this is spam classification. One reason for the predictive capacity of pre-trained language models is their large number of parameters. This becomes an issue if we start applying such models on a large variety of tasks and textual domains. If we fine-tune pre-trained language models for each task, we end up with a large number of models only usable for that specific application, and this is very parameter inefficient. That is, it requires a lot of memory storage and computational power. So the question came whether a model's parameters can be reused when fine-tuning on a new task, and this is what adapters have been introduced for. So adapters are small modules, also called bottleneck layers, between each layer of a pre-trained language model. During training, the parameters of the original language model remain fixed and only the adapter weights are tuned. It has been shown that this can lead to similar performance, but reduces the number of trained parameters by up to 2 orders of magnitude, as you can see in the table which is displayed in the slide. Thus, one can train adapters on various tasks using the same pre-trained language model and thereby tremendously reduce the amount of storage and computational power required for those models. While large pre-trained language models are easily accessible and can be stored and shared via the Hugging Face repository, just to give you one example, no comparable library has existed for sharing the adapters. And for this purpose, we introduced the Adapter Hub framework in 2020. In principle, it is comparable to the Hugging Face library, being a community-driven repository to exchange and share pre-trained adapters for a large number of different tasks and languages. While we provide a set of pre-trained adapters to the community, many new adapters have been contributed by the community in addition so far. Now let's look into the playground application specifically. As I have already presented in the beginning of this talk, we envision the following exemplary scenario. A researcher has collected textual data for a given task. In this example, this is sentiment prediction, and then she wants to perform analysis using text classification. She has a label test set to evaluate the performance of the classifier, and she also has a set of texts from the same data distribution as training data. However, that text is not annotated. For this scenario, the Adapter Hub Playground provides the following functionality. First, we enable access to pre-trained adapters from the Adapter Hub for text classification without writing any code. Second, existing adapters can be used for prediction, but they can also be further fine-tuned using existing annotations. And finally, we can also use it to visualize our classifications, possibly highlighting relations between multiple predictions. Here, I would like to provide an overview of the typical application workflow. In the first step, users upload their textual data to Google Sheets. We use Google Sheets because it provides convenient upload for different kinds of files like CSV or Excel or other data formats. And also Google Sheets can be conveniently accessed through an API. Further, it keeps our application lightweight by reducing the storage capacity requirements. In a minimum working example, the uploaded data needs to contain some text samples. If the user additionally provides labels, the predictions can be evaluated using those labels, or they can be used for training an adapter. In step number 2, the user creates a new project and links the Google Sheet to it using the share functionality of Google Sheets. In step number 3, users can create an action by selecting a specific action type. Currently, we offer 3 action types: clustering, prediction, and training. And both prediction and training use pre-trained adapters from the adapter hub. Based on the task selection by the user, for example, sentiment analysis, the specific adapters are dynamically retrieved. Then the adapter is used for generating predictions or training on labeled data. This is enabled via dynamic code generation. In step number 4, and after generating predictions, the user can visualize the results within the project. We replicate our envisioned scenario with experiments for sentiment analysis in English. We use an existing data set for training and predicting sentiment in Twitter. We further compare 3 adapters which are available on the adapter hub. They have been trained for the same task, but using different data sets like IMDb, RT, SST2. They come from different textual domains and they vary with regards to their data size. In our experiments, we use varying sizes of training data to investigate how many instances a user needs to annotate to outperform the pre-trained adapters which already exist on the adapter hub. In NLP, we refer to such a scenario as a few-shot setting, where the goal is to identify how many annotated instances I need for substantial improvement on the target task. The table shows the results of several experiments. The very left column after the data sets shows the performance when using 0 annotated data from the target task, and the most right column shows performance when using all available training data. We see that already using 10 annotated instances for training leads to better performance. However, we have a large standard deviation that shows that the results are not robust across different subsets of the data. Using 1,000 examples, that is training instances, leads to a substantial improvement of performance while also being more robust across different subsamples. Finally, I would like to show you the application in action, and I would like to ask to start the video here. Thank you very much. Can I go back to my slides? So I'd like to summarize the main conclusions of this talk. The Adapter Hub Playground is a web application for text classification that we can use without writing any code. It provides functionalities for training and prediction using pre-trained adapters from the Adapter Hub repository. Currently, we offer support for several prominent text classification tasks like sentiment analysis or semantic similarity. We built the framework with considerations for high usability and extensibility, and all our code is open source. It allows for comparing predictions of multiple adapters using various visualization techniques. Finally, no special hardware is required when using third-party computational resources, and alternatively, it can be hosted on a local compute server as well. Thus, the framework can be used by any party without great difficulties. Thank you very much for your attention. That's all. And Tilman and myself are very happy to answer any of your questions.
So there's one question I would read out loud. How to work with open source NLP in security restricted data environments?
Well, I actually did not understand the question properly. So the answer, what is security restricted data environments? And the answer is sensitive data. Is Hugging Face is anyway ready for enterprise use cases? What are the alternatives? So I don't see any particular restrictions that the software can be used with the sensitive data, because the software is used locally. So it's not run on a server by a third party in general. However, any complex application like ours, for example, which uses Google Sheets, does contain different risks that need to be analyzed, and special privacy considerations need to be made, or another model maybe should be developed for that. But being open source does not prevent the software from being used with the sensitive data. Tilman, do you have any comment?
Yeah, I totally agree with you, Irina. So I think when we developed the adapter playground, our one criteria for us was that you can use this with your own data and without the requirement of hardware, because for our target audience, this was a big hindering step, that they needed some kind of GPU access. And in this case, this was our first priority, that people can use it without having access to their own GPU server.
Thank you. Are there any other questions? So it seems like there are no other questions. So then I think we can thank the audience for being with us, and wish everybody a great weekend ahead. Thank you very much.
Thank you.
Thank you. Bye-bye.
Bye-bye.
Bye.